let me say something about the way we're going to do this in WebGL. So here's our Vertex Shader. So this should look reasonably familiar to you, right? We have an attribute which is passing in position. Here they have an attribute passing in color. And you're probably already working on this in your assignment, trying to get the color attribute to work or a UV coordinates attribute to work. We can pass a couple of matrices in. So far in our code, we've passed a UModel matrix. This is the one you were using to move your boxes around. This piece of code didn't have it. It would go right here. So the order of these matrices matters, as it always does with matrices. So the modeling matrix is the first thing that happens to the point, right? The point is in the cube coordinate space. And then we apply our model matrices to put the cube where we want it in the world coordinate space. So this gets the head of our creature in the right spot. So this is a modeling transform. So now we have our points in that space. The next thing is this view matrix, which is going to be dealt with by look at. So this is going to move all of these points so that we're in the eye or viewing coordinate space. So this is putting the camera on the origin looking down negative z, is what this matrix is doing. So after our points multiply by this, they've all been changed around, but there's been no perspective yet. And the last thing we do is this projection matrix, which you will be setting to perspective. So far, you don't have a viewing and a projection matrix, really. You just have the model matrix. So you could pretend these things are set to identity right now, right? So your viewing and projection are just set to identity. And now in this assignment, you're going to set them to something different. So we're going to be able to move around the camera, and we're going to set the projection to actually do this crazy squish on the world so that when things move into the clip coordinate space, the stuff closer is bigger and the stuff further is smaller. So we want to pass these things explicitly and this. So we're going to have three matrices to pass into there. So where do we define this? In the old OpenGL, there was a GL command for doing frustum. And they were utility commands. They were considered sort of extra helper functions for doing look at and perspective. So here they're not in WebGL directly. They're in our matrix library. So the book has provided this matrix library to you, and you've extended it a little bit with a vector class in assignment 0. So inside this, if you want to go see how it's defined, you go look inside the con.matrix file, and we have this matrix class, and one of the commands it has is set look at. It's the same way you have set translate, set rotate, we can set look at. And the look at command takes I and at and up, separated into XYZ. So I've got 9 parameters that go into here. And this generates a matrix, which is going to pass all the way through into our shader. Same thing for the set perspective. We take field of view and aspect and near and far, and we set this. Now you could also call a set ortho command here and set up an orthographic camera rather than setting a perspective. So this is also something that the matrix class defines for you. Of course, you pass these things in and do your draw raise as usual. So it's pretty straightforward to actually set up the camera. It turns out to not be too complicated. You're going to spend more time in your code figuring out, well, how do I know which numbers to stick in here? And when the user says they want to move to the side, what does that mean? Where am I supposed to move my add and my up? These are things that you're going to spend more time trying to figure out. And it's discussed both in the lab section and in the videos that I've provided. Questions about how to deal with this in OpenGL or where it's going to go in your code? I see there's a question about the previous thing we were talking about this crazy camera lens. I think it was called View Camera or something like this. If you Google a little bit and you don't, I'm sure there is a name, and I can't think what is it right now. I've never bought a lens like this. They tended to be professional, expensive lenses. If you don't find it quickly though, send me a note and I'll go dig up what the heck this thing is called. I can't remember.